Lesson 51 is about graphs of linear equations. I think the best way to explain this is just to do some practice problems. So look at practice problem A. Y equals 1/2 x plus 2. Now that looks like the polynomial equations that we were studying in lesson 50. And if you recall in those, what we did was we said that y was a dependent variable because its value depended on what value you put into the equation for x. And we said that for whatever x value, there was one and only one y value that would combine with that x to make that equation a true equation. Those xy pairs, we considered those ordered pairs, and there's more than one ordered pair that will work in that equation. In fact, there's an infinite number of ordered pairs that will work in that equation. And it's interesting because if you plotted several of those ordered pairs on a Cartesian coordinate system, you could see that they follow the pattern of a line, and that's why we call them linear equations, because they follow the pattern of a line. So to graph a linear equation, what we need to do is find several xy pairs, and then we can connect the dots in between those xy pairs after we plot them on a Cartesian coordinate system and make the line represented by that equation. Hopefully you know that you need at least 2 points to define a line. So let's go ahead and take this equation, y equals 1/2 x plus 2, and the first thing you ought to do on these to figure out some ordered pairs is just make a little table, an xy table, and then choose some values of x that you could substitute into that equation and find corresponding values of y. In other words, make some ordered pairs. Well, look at this problem. Y equals 1/2 x plus 2. Let's use a -2 as an x value to substitute in there. We only need 2, but let's go ahead and figure out 3, because the more points the better. It'd be easier to draw a line through them. And let's use a 0, and then let's use a +4. The reason I'm using those even numbers is because I have a half there. I know I'm going to multiply that half by another number, and that way I won't end up with a fraction for an answer. I mean, it doesn't really matter. There's an infinite number of x values we could pick. I'm just using those particular 3. And so now let's go ahead and find the corresponding value of y for each of those x values. When x is -2, we'd have 1/2 times -2, which would be a -1 plus 2, so that'll be a +1. Then when x is 0, we'd have 1/2 times 0 plus 2, which will just equal 2. And then when we have a 4 in there, we'd have 1/2 times 4 is 2 plus 2 equals 4. Okay, so now we have 3 ordered pairs: -2, 1, 0, 2, 4, 4. We only need 2 to make a line, but let's just go ahead and use 3. And another reason we use 3 is just in case we messed up on one of them. If we don't get a linear pattern with our points that we plot, then we know that we made a mistake somewhere. So go ahead and make yourself a Cartesian coordinate system somewhere on your paper. Just make one big one, and you can use it for all of the practice problems that we're going to do with this lesson. So we have a Cartesian coordinate system now. Let's go ahead and plot those points. -2, 1 is one of the pairs that we can plot, and so we'd move to the left 2 and up 1. Put a dot there, and then the next one is 0, 2. So on that one, we don't move left or right on the x-axis. We just go straight up 2. And then the last one is 4, 4. So we go to the right 4 and up 4 and put our point. And we can kind of see that linear pattern there that those points are following. So now all we have to do is just draw a line through those points. And there's our line that is represented, that function represents. So first degree polynomial equations, they have a linear pattern to them. When you graph them, they have a linear relationship, or they represent a line. Let's do another one, y equals x minus 2. Now this one, the terms are different, the polynomial equation is different, so we'll have a different line that we'll graph. First though, let's make an xy table. That's always what you want to do as your first step. on these problems. Make an XY table, and then let's choose some convenient values for X. And when I say convenient, I mean we don't want to put 1,233 in there for X. We could, but that's just not very convenient, especially when our graph only goes like 5 or 6 tick marks away from the origin. So let's use a -1, a 0, and a +1. And try to remember that. We just try to pick convenient values for X. 3 is a good number. You could make 5 if you wanted to, if that helps you plot your points a little bit better. You could even make 10 points if you wanted to, but I usually just use 3, and I just pick some values of X that are easy to work with mathematically. So we have X equals -1. When it equals -1, Y would equal a -3 because we have -1 minus 2 is -3. When X is 0, Y is -2. And then when X is negative or +1, Y would be 1 minus 2 or -1. Okay, now let's go ahead and plot those points on our Cartesian coordinate system. And the first ordered pair there is -1, -3. So we move to the left 1 and down 3 and put a point there. Then the next one is 0 and -2. So we don't move to the left or the right. We just go straight down 2. And the last one, we move to the right 1 and down 1. We put our point right there. And so you can see the linear pattern that is developed there by plotting those points. And so we can just draw a line through those 3 points. And there's the representation of that line. See, it's sloped a little bit different than the other one, and it passes through the y-axis at a little bit different spot as well. And so we can see the equation, and we can see the line on the Cartesian coordinate system, and we can tell it's different than the previous equation's line. Let's do one more. This one is y equals -x plus 1. This is a polynomial equation in 2 unknowns, just like the other ones, a first-degree polynomial, so we know that this will have a linear pattern to it when we graph it. Let's just go ahead and make an XY table. Choose some convenient values for X to put in there. Let's use 1, 2, and 3 on this one. And so when X is 1, we'd have -1 plus 1. Y would equal 0. When X is 2, we'd have -2 plus 1, or -1. And when X is 3, we'd have -3 plus 1, or -2. So now we have 3 ordered pairs. We need at least 2 to plot a line, but we've got 3. Let's go ahead and plot our points and then draw a line through them. So the first point is 1, 0, to the right 1, and then we don't go up or down any. So we just put a point right there. The next one, we'd go to the right 2 and down 1. And then the third one, we'll go to the right 3 and down 2. And so you can see those points, they're following a linear pattern, so you just go ahead and draw a line through those points. Notice how that line is sloped differently than the others. The other two are kind of sloped uphill if we were looking at them from left to right. Say you were like driving a car up them from left to right. You'd say that they had a slope, an uphill slope to them. That other one has a downhill slope. But notice it has a negative in front of the x. The other two equations don't have a negative in front of the x. That makes the difference in how they slope, whether there's a negative or a positive sign in front of the x. Now let's do a couple of unique linear equations. Look at practice problem D and E. In D we have x equals 3. I want you to graph that. That can be a line. You can represent x equals 3 as a line, and all you do on that is you just find 3 on the x-axis. You just go over 1, 2, 3, and you make a vertical line straight up and down. That represents x equals 3. If we had said x equals 2, we would have drawn a vertical line right through x equals 2. If we said x equals -5, a vertical line right through x equals -5. So In E, you can probably guess there, it's y equals 4. If you graph that line, you would be drawing a horizontal line right through y equals 4. So you go up 4 on the y-axis, just draw a horizontal line right through y equals 4. If that was y equals 1, we would have drawn a horizontal line right through y equals 1. If it was y equals -2, we would have drawn a horizontal line right through y equals -2. So make sure you distinguish those two things, the difference between a line when it's x equals something and the difference between a line when it's y equals something. You just draw it through that point on whichever axis it's describing. And so you'll have problems where it says graph this equation on a Cartesian coordinate system, or graph the equation for this line. And so you'll just do that. You'll just make it a Cartesian coordinate system, or an XY axis if you want to call it that. Same thing. If you have a problem like A, B, and C, set up your XY table, choose you some convenient values of X, find the corresponding values of Y, plot those points, and draw your lines. If there are problems like D and E, you just have to look at, is it X equals or Y equals, and then draw it through the corresponding point on that axis. Okay, well that's all for lesson 51.